Okay, all right. Well, hello everybody, and I hope you guys are doing well. We are going to continue on in our textbook today, and I'm going to go ahead and skip ahead to chapter 11 in our textbook. So the last chapter we covered was chapter 8, and that was on strings. And I'm going to go ahead and move to chapter 11 here. And the reason for that is because chapter 9 is an application of kind of strings and iteration, and there's some really good exercises in here. And so I don't want to work through them in class. I want you guys to do these exercises. So this will appear in your next homework assignment. Um, they're short and they're quick, but you'll see how powerful some of these string methods are. Okay, and then chapter 10 is all about lists, and we've been covering lists a little bit on and off throughout the other part and a few of the other lectures. So I'm going to go ahead and skip chapter 10 as well. And again, I will put in some exercises here, and again, you can always just kind of glance back through the rest of the chapter if you need to reference anything in the content and material. But you can expect to see some of these exercises to appear in the homework as well. I guess I should just ask. All right, I hope the second homework assignment is going well. The homework assignments will probably progressively get more difficult as we go along. Or at the very least a little bit longer. But that's what we've got going on here. And so today we are going to cover dictionaries. Okay. And so this is coming from chapter 11, and that's what we've got going on there. Okay. So a dictionary is a mapping. Okay. And what it is, and they're unordered mappings, and they map keys to values. All right. So you can, if you're coming from R, you can kind of think of it as like named vectors and stuff. But like lists, they can contain different types of data. All right. And then you'll create dictionaries using curly braces. Okay. So curly braces to kind of say this is a dictionary, and colons. There's also the function dict, D-I-C-T, to define a dictionary. So that can be done. So here we are going to create a dictionary where we are going to map the key Adam to 25, Bob to 19, and Carl to 30. So maybe these are people's names and perhaps their ages. I don't know. I'm just making stuff up here. Okay, so we've created a dictionary. And if we ask what is the contents of people, this dictionary people, this is how how Python prints it out. Okay, and it looks like this. Now, in this case, the dictionary, the order here is printed in the same order that we entered it. But this is not always going to be the case. Dictionaries are inherently unordered, and Python may choose to when it prints it out, arrange things in a different way. Okay. There's a few other ways of creating dictionaries. Okay, so this is not mentioned in the textbook, but this is often handy. Is that you might have two lists. Two lists are of the same length. Okay, so here I've got a list Adam, Bob, and Carl, and a list of numbers, integers 25, 19, 30, and I can zip them together. And when you zip things together, it creates what's called a zip object. It's a little it's a little weird. It's an internal data structure that Python uses, but it naturally transitions very well into a dictionary. So you have to take the zip and you can put it inside the dictionary structure. Okay. And again, you can also just create a dictionary using the dictionary structure right there directly, okay? And so this is what a zip is, the output of a zip function. It's going to be this object. It says a zip at this memory location. But here we've finished creating people2, and this slide, or I'm sorry, this dictionary that we created back on this slide is exactly equal to the dictionary that we've created here with people2. All right. We access values in a dictionary by referencing the key in the dictionary. All right. So here we can say, what is the value associated with the key Bob? Okay. So here Bob is the key, and its value is 19. Does the key have to be a string? The key does not have to be a string. The key can be numbers. The key can be strings, numbers. The rule is that the key has to be a immutable object. Okay, so so the key doesn't have to be a string. All right. So here we have this Bob people.get. You can also retrieve the value by using the get method on a dictionary. Okay, and this returns the same value, 19. Okay. The difference between using the square brackets is probably the most common way of doing this. But a difference is that if you ask for a key that doesn't exist, right? So I think we've got Adam, Bob, and Carl, or something like that. If you ask for Joe, okay, you get an error. Okay, you get a key error for saying that because this key doesn't exist. However, if you call get on the dictionary, so if you do people.get, right, then it doesn't return an error. It'll just return none. Okay. And then with get, you can actually also specify a default value, right? And so you can say if you don't find Joe, return 0. Okay. By default, get will return none. Okay. Which I had to call print here because if I ran this and it returns none, and in Jupyter, when the value that gets returned is none, it doesn't print anything out. So if you print out the results of this, you get none. Okay. Otherwise, it will return. You can specify something here. Okay. You can say return the value 0. All right. Keys can be numeric, and the values can be lists. Okay. So here, this says the key is 2, and the value it returns is this list 24 and 5. Here the key is 1, and the value it returns is 10. Okay, yeah, I know in our brains, for a lot of people, when you see R, you automatically think this is the numbers 1 through 10, but that doesn't exist in Python. Okay, in Python we use range objects, right? So you do like range 0, 5, or range 5. So keys can be numeric. So here is a dictionary with 2 keys, the number 2 and the number 1, and we can ask for, hey, what is the value associated with key 2? What is the value associated with key 1? Okay. Now this, when you look at this, you might think this might look like the way we subset or pull elements out of a list. Okay, and it's tempting to look at it that way, but it's not. Lists are ordered. The first element in a list has index 0. The next element has index 1. The following element has index 2. But dictionaries are unordered. Okay, so if you try to use numeric index, right, and if you say like give me people at 0, okay, and in a list this would work. This would give you back the first element. It would give you element at index 0. But for a dictionary, this doesn't work because it's looking for a key. It's looking for key 0, which which doesn't exist. The keys in the people dictionary are the names Adam, Bob, and Carl. So this is not going to work. So we've got, so we get a key error here, okay? There is the in operator, okay? The in operator will just check to see if a value exists inside the dictionary, not a value, I'm sorry, if a key exists inside the dictionary, okay? The in operator applies to the keys. If you want to check the existence of a value, you have to use a view object that references the values, right? So we can say is Adam in people, and that returns true, okay? 19, which is, I think, Bob's age, is 19 in people, that returns false, because 19 is not a key that exists in the dictionary people. So that comes back false. But we can say is 19 in people.values, and that comes back true, okay? So you can say in the values, we've got people.values. There's also view objects for the keys. So if you just want to look at the keys, you can do people.keys and stuff like that. People.items will be a bunch of tuples. Okay. So the in operator uses, this is just kind of an internal note regarding how Python runs. The in operator uses different algorithms for lists and dictionaries. And so for lists, it searches the list in order, okay? It starts at the beginning and it goes to the end. And the longer the list, the longer the search takes. Now, probably, unless your list is like millions of elements big, these things feel very instantaneous, okay? But yeah, if you do have a giant data set, okay, or a giant list, then your things can run slowly, okay? Lists are actually kind of slow as far as things go. They're a very commonly used data structure, and we love them. But if you're trying to go for quick things, lists are not the fastest out there. Well, we can look at NumPy later, which will have arrays, which are faster and things like that. But anyway, dictionaries in Python use what's known something called a hash table, okay? And all the keys get hashed, and that basically converts everything into some kind of integer, and then you can look things up. So anyway, even if you have a giant dictionary, Python is able to check if an element exists inside the dictionary very quickly, okay? So whether you have a short dictionary or a long dictionary, it takes about the same amount of time, which is pretty cool. So it was a data structure built with kind of this lookup functionality to be very, very quick, okay? It was done with the speed for the lookup functionality in mind, okay? So, oh, okay. So this is how we can create new entries in the dictionary, okay? So at the beginning, we said, you can just define the dictionary. And we define the dictionary. We just wrote it ourselves, right? We just said, here's the key, colon, value, key, colon, value, key, colon, value. And we just wrote it out ourselves, or we took two lists and we zipped them together, right? But let's say we want to add elements to our dictionary, all right? This is how we can do it, all right? So here we can do, you give it a new key, a key that doesn't exist, and you give it a new value, and this will create a new entry in the dictionary, right? If you give it a key that does already exist, like Adam, and we say, all right, Adam is now 26, okay, this will modify the existing key value pair. Okay, so this is what we get. All right, if you want to, so this is the result. Adam has now been updated, and Derek is now added as a key in there. If we want to remove a key, we can use delete, okay? So we can say delete Carl from people, Carl, all right, and the result is people is now modified, okay? The dictionary gets modified. So dictionaries are mutable objects. This will mutate the dictionary, and the dictionary itself is changed. Okay, you can, so if you remember the pop method that exists for lists, it also exists for dictionaries, okay? But when you apply it to a dictionary, you have to specify a key, right? Okay, why can we not use pop without a key? Well, what pop's default behavior is that it will default to popping the last object in a list, right? So if you have a list, or I should say the last element in a list. So if you have a list and you apply pop to a list, it's going to pop the last item in that list, okay? But you have to think of a dictionary as being unordered, right? It might be handy to, if you think of a dictionary, you can think of it as just a bag, right? A bag with stuff in it, okay? And if when you reach in the bag and you say, well, give me the last item in the bag, that question just doesn't even make sense, right? There's no, it's not a stack. There's no order to objects inside a bag. So if somebody says, use pop, give me the last item in the bag, that just doesn't make sense. So here, if you call pop on the dictionary, it doesn't work, right? So you have to say pop some kind of value here, okay? I'm sorry, you have to give it some kind of key name. And so here we're going to have pop Adam. Adam is the name of the key, and it returns the value associated with Adam, and it modifies the resulting list or resulting dictionary. Okay, so when we print out the dictionary, it comes back, and Adam has been removed from the dictionary. Okay, so this can be useful if you need to kind of I don't know, remove things simultaneously while getting their value. All right. So I showed you adding elements. This is deleting. Okay. You can add elements using this. Okay. There's also a method called update. Okay. So you can take a dictionary and use update, and you can add more keys and values. Okay. And so here I have two dictionaries. Okay. And what I want to do is I want to add all of these things to this dictionary, okay? And so, you know, with a list, it was doing something like this was kind of easy. You could use append, or you could do the plus operator, all right? And that would kind of put the lists together, right? With a dictionary, though, we're going to do update, okay? And we specifically use update because this handles kind of the situation where you know, what would happen if you kind of give it something with the same key. So anyway, we got I guess traditionally masculine names A, B, C, D, E, F, and we're going to run the dictionary. So I'm going to do people A, which is a dictionary, and we're going to update it with the keys and values that appear in people B. Okay, so we've got people A, and then we call update using the keys and values in people B, and the result is now people A is now a longer dictionary with all of these people A, B, C, D, E, F. Okay, and it's just coincident. Well, you know, for these smaller dictionaries, Python often when it prints it out, often prints out in the order that we might expect, in like kind of the order that they appear. But again, dictionaries are unordered. There's no inherent ordering. You can't count on any kind of ordering to exist here. Okay. So this is how you can kind of extend a dictionary with more values. Okay. if the dictionary you use to update has keys that already exist in the first dictionary, then the keys will be updated with kind of the new values. All right. So here I've got Adam, Bob, Carl, Dave, Earl, and Fred. And I've got a dictionary here that says Fred is 99 and Gary is 18. Okay. So if I do people A dot update people C, okay, what it's going to do is it's not going to create a duplicate entry with Fred. Okay. So instead, and now because it doesn't fit in one row, it prints it out vertically here. But we can see this updates with the name Fred, and Fred's value gets changed from 27 to 99, and Gary gets added with a value of 18. All right. This is okay? All right, so there's something known as dictionary view objects. Okay, dictionary view objects are pretty cool features of dictionaries. Okay, and you can just access them by using either dictionary.keys, dictionary.values, or dictionary.items. Okay, and what a view object is they're actually dynamic. Okay, and so the values or whatever appears in the view object will change as the dictionary updates. Okay, so here I redefine a new dictionary of people. Okay, so this is creating a new dictionary with just 3 keys and values in it. And here's what the dictionary looks like. Okay, I'm going to create 2 objects, 2 view objects. Okay, names will be people.keys. So that will collect Adam, Bob, and Carl together. Okay, so that's going to collect the keys together into this view object called names. And then and values, people.values will collect the values, and that will get put into this view object that we're going to call ages. Okay, and so when I call and I ask names, it looks kind of like a list, okay, but it's a view object. It's going to say dictionary keys, okay, of this 8 and above Carl. Oh, and then ages basically has the same thing, but 25, 19, and 30. So sorry, I guess I'll have to reformat that. Okay, so here, so this is kind of the neat thing about view objects is that if I create a new entry, okay, so if I create a new entry, say Ed, age 40, add it to my dictionary, the view object for names is updated, okay, without having to needing to redefine it, okay. So names gives us a dynamic view of what the names are that are inside this dictionary. Okay, same thing with ages. Okay, the ages is a dynamic view to the values inside the dictionary. So as soon as I enter this thing into the dictionary, the view objects of names and ages get updated. View objects only support a couple functions like length or in, all right? And if you need to do more with a view object, okay, other than ask for is it in here or is, what's the length, you can convert the view objects to a list or some other kind of iterable type like a tuple or something. But if you do that, you're going to lose the dynamic quality of the view object, all right? So for example, right now, ages has these 4 elements, 25, 19, 30, and 40. Okay, and I can just say, what is the length of ages? Okay, and I could say, is 35 a value in ages, right? 35 in ages, and that returns false. Okay, I can convert this list to ages, okay, and that's going to just take, what that's going to do is it's going to take these four values, 25, 19, 30, and 40, and it's going to kind of create a snapshot, okay? And now this list, okay, this, when I take the ages view object and I put it inside a list, okay, we get a list here, but this is no longer dynamic. This is now static. This is basically disassociated with the dictionary, okay? So here, if I update the dictionary, right, and if I say, hey, let's add Frank to the dictionary, Frank is 29, okay? The view object is dynamic, and that gets updated, okay? 29 appears in the view object ages. But then if we ask, what is the list that we created earlier, that is static, okay? Now that once I've created it, it's no longer associated with the dictionary. So the view object will continue to update. It's always a dynamic view in the into the keys or the values that we've created. But again, the view objects only support really these functions. You can ask for the length of the view object, or you can ask if a certain element is in the view object. Other than that, there's not a whole lot you can do with it. Okay. But even those functionality is very handy. Okay, it's still very handy to have that functionality. So here we go. Okay, again, if we try to use, so ages again is the view object, and if I try to say, hey, give me object at index 3, okay, it's going to tell you that the view object does not support indexing, okay? Again, because dictionaries are inherently unordered, and so their view objects are also going to be inherently unordered, okay? And then as far as the view object goes, the view objects no longer have any kind of association to their keys, right? So if we can ask what is the value associated to Bob in the dictionary, but once you create a view object, that's not the purpose of the view object, right? So you can't subscript a view object, for the values, right? So if you want the age of Bob, just do that directly on the dictionary itself, right? Okay, and then the other view object, so we had dictionary.keys, dictionary.values. You can also call a view object on the items themselves, okay? And then the items themselves will be tuples. So we've got a view object, which looks like a list, but it's a view object, and it contains all the elements in the dictionary, which is a bunch of tuples. All right. I don't know if there's any questions here as far as dictionary objects and their the view objects. Okay. All right, so we can look at a couple applications. This is taken straight from the textbook. So one is you can use the dictionary as a collection of counters, right? So there's tons of applications of dictionaries. Dictionaries are a very powerful data structure to have in Python, and there's all sorts of things, right? So here's just a kind of an imaginary or silly scenario. Is let's say you've got a string and you want to count how many times each letter appears in the string, right? More broadly speaking, this kind of application can be used in, say, like natural language processing, where you have a document and you split the document up into words, and you just want to create a kind of a word count vector of all the words, right? You can go through the document and you can say, this is how many times the word the appears. This is how many times the word a appears. This is how many times the word house appears. And you can kind of create a dictionary with a bunch of counters, right? So anyway, here's a few ideas and approaches that we can use to perform this task of taking a string and counting just how many times a particular letter appears, right? And so this is one idea. This is not the best idea. So ideas 1 and 2 are probably not the best. But you could say, hey, let's make 26 variables, one for each letter of the alphabet. So we're going to have a variable for A, a variable for B, a variable for C. And then what we'll do is we'll go through the string, each element of the string, and then we're going to say, oh, here is the word, let's say we go through the word character. We're going to say, oh, okay, here's the letter C. Let's add 1 to the variable that's keeping track of C. Here's the letter H. Let's add 1 to the variable keeping track of H. Okay, so that works if you got kind of just a finite set, like the characters of the alphabet. We know there's 26, so we can set up the 26 variables in advance. But if we were doing like a word counter, this would not work, because we would need a variable for every single word, and we might, the document might have words that we've never seen before, right? Okay. Similarly, we could create a list with 26 elements, one for each letter, and then you could convert each character to a number, and then, using the number as an index into the list, we can kind of increment the counter, right? But again, that would require us to know in advance what, like with the letters, that's fine. We've got 26 of these things defined. But again, if we wanted to do like something with words, we would have to know kind of all the different words that would appear, and that's going to be problematic. So a dictionary can act a little bit more dynamically. It can kind of just say, hey, let's start with nothing, and every time we see something new, we're going to create a new entry. And if we see something that we've seen before, we can just add 1 to it, okay? So this will work well for letters, but it will also work for going through a document, okay? This is the first time we're seeing this word, so we're going to add it, and we're going to say we've seen it 1 time. And then later on, if I see that same word again, I can increment the counter, okay? And so dictionaries are really good for these kinds of setups, okay? So we're going to go ahead and use the dictionary approach, and here is the code that we're going to use, right? The book calls this function histogram, which I guess histograms I've always learned, and we're like the stats major, right? We've always done something like going through for a numeric thing, right? Okay, Jason says, I miss an R. You can do table on factors on the string. Yeah, so yeah, you'd have to first parse up the string into individual letters, and then yeah, you can convert it into a factor, and then create a table on that, and that will work. That will work in R, and that requires kind of a lot of R's internal things. Okay. Python actually has some functions, and I guess maybe I'll bring it up in the future. Okay, so this is if we were going to code it ourselves. There's a whole kind of module in Python called counters that do these kinds of things right away. But I guess in today's lesson, when we're talking about dictionaries, this is like a we're going to do the code ourselves, right? But yeah, stuff like this exists already in Python. Okay, so here I'm going to just create an empty list with a dictionary, okay? And I just use empty curly braces. I could also just call DICT for a dictionary. And then we're going to traverse the string. We're going to go for each element, character in the string, right? Because a string itself is an iterable object. So we're going to go for each character in the string. We're going to ask, we're going to say, if the character is not in D, then define basically a new key inside the dictionary and set the value equal to 1. And this is, I just love Python's language structure. It's so clean and easy to read, right? You just say if If the character not indeed, this just feels like you're speaking English. um, um, right, so we've got the in operator, not in D. So in D is a Boolean operator, and then if it's not, then we will do this, okay? And otherwise, we're going to take the current, we're going to look up the value associated with the character, and then we're going to increment it by 1, okay? So plus equals 1 basically takes this value, adds 1 to it, and stores it back here, okay? So plus equals 1 means increment the value by 1, and then at the end, return the dictionary, okay? So yes, there are functions, there are counter functions that will do things. So anyway, so here is the word brontosaurus, and it goes through and it says B appears 1, R appears twice right here and right here, O appears twice with O and 1. The brontosaurus actually doesn't exist. Did you know this? It's not a real thing. It turns out that the skeleton that they used to establish the brontosaurus, and they thought was a separate species, is actually the apatosaurus. The apatosaurus was discovered earlier, and so the naming conventions is that the apatosaurus is the real name, and the brontosaurus, which they thought was a different species at first, was exactly the same thing as apatosaurus. So brontosaurus it's not a real dinosaur, okay? I think. I'm pretty sure I read that somewhere. I could be totally wrong. Okay, anyway, so this is, look this up. Now I feel like compelled to look up whether a brontosaurus is real, whether I told you a lie or not. I'm pretty sure I told you the truth. Okay, okay, so once you've established the dictionary, right? So we've got the dictionary here. We can use it in a loop, right? And so we can just say for key and H, let's just print out the key and let's print out the value associated with the key, okay? So I mean, of course, there's a lot more you can do with when you're looping or iterating over some kind of dictionary, okay? And so here it goes through and it's just printing out the values. This is about as boring of a loop as you can make. And here it appears like these letters are in the order of appearance, and I think for this dictionary that is the case, but that's not always going to be the case, all right? And this is a very key thing, is that when you're dealing with dictionaries and keys, you cannot count on them to be sorted in any meaningful way, okay? For a lot of small cases, when you create a dictionary, it appears like they are in the order of appearance and the order of creation, okay? But that is, but you cannot count on them to be sorted in any kind of meaningful way, right? So that's important. If you're expecting them to be sorted in a certain way, you will be disappointed, all right? And so if you do need them to be in some kind of order, you can use sorted, you can use some kind of other type of thing. Yes, a very key thing, yes, yeah. I like your pun. Okay, thank you. So you can apply a sorted, and this will apply a sort operation on the keys, and it will put the keys in alphabetical order. Okay, so those are some things you can do. Okay, so dictionaries are designed to go to look up the key and then find the value associated with it. All right, so that's what the regular dictionary use is. Okay, sometimes though you want to find you have the value and you want to find the key associated with the value. Okay, to do something like that, you have to do a reverse lookup, okay? But this is dictionaries aren't designed for this, and you're not going to get great results, especially. Okay, so here, here's one possible reverse lookup. This is like a really junky reverse lookup solution, okay? But what we're going to do is we're going to just go through each key in the dictionary, and we're going to say, is this key equal to V? And if so, give me back the key. Is not a good solution, okay? It'll work, like it'll give you an answer, but what happens, right? Like if I say, look, give me the key associated with 2, what's it gonna do? I've got R, I've got O, I've got S, I've got U. Which one of these is it gonna return? Okay, and we have no idea, right? Because when I say for key and D, there's no order there, right? This is going to be, this behavior is completely unpredictable. Okay, I could minimize a little bit by saying like for key in sorted D and stuff, and then I can at least say like it's going to be the first in the alphabetical order. But okay, but anyway, so this kind of sucks. But anyway, one thing I do want is so if it finishes the entire loop, right? Right, so it goes through every key in the dictionary, and hopefully it encounters something and returns, right? And as soon as it returns a value, the function ends. But if it gets through this entire loop, okay, and doesn't return a value, then it's gonna raise an exception, okay, a lookup error, and we tell it value doesn't appear in the dictionary. So if it gets through here, it's going to raise an exception. So here's H. We're going to call reverse lookup on the dictionary is called H. Reverse lookup on this dictionary for 2, and it gives me back R. Okay, so it looks like it's kind of going in this order, but I'm not quite sure the order that reverse lookup search is doing here. Okay, and if I say 4, it got cut off here, but it gives me a lookup error. Okay, lookup error, and then the very last line is going to be the error message that we've written here. Okay, so not great. Dictionaries aren't really designed for this. Okay, it can be done. It's not designed for that. Okay, so anyway, just a little bit about the raise statement. You can click this link and look up all of the, oops, I didn't want to do that. All of the different kind of exceptions. There's like name errors and key errors and stuff like that. All right, so here's a slightly better thing, okay? I'm missing stuff here. We can take the dictionary and we can do an inversion. So here's some code that will invert a dictionary, okay? So when we invert this dictionary, what we're gonna do is we're gonna take this, so here I run histogram on parrot, and it gives me P appears 1, A appears once, R appears twice, O appears once, and T appears once. And what I'm gonna do is I'm going to invert the dictionary, okay? And the result of the inverted dictionary is a dictionary itself, okay? And what we're going to do is we're going to traverse all of the keys in the dictionary, okay? And for each key in the dictionary, we're going to take the value associated with that key. And then we're going to say, is the value inside our inverted dictionary, right? So is the value inside the inverted dictionary? Now, keep in mind, when we call in, it's checking for the keys. So now we're taking the value here. So we're going to take, so let's pretend the first element here is P and I, okay? Or P and 1. So we're going to say, okay, let's go at P. The value is 1. Is 1 one of the keys in the inverted dictionary, okay? And if it's not, okay, then add an entry here, okay? The entry is going to be, for the key is 1, enter the letter P for the value, okay? And if it already exists, then look what we do. We take this and we append So the next entry is, let's say we go to A, okay? So when we did P, we start off with an empty dictionary. Now after the end of the dictionary, after the end of my first iteration of the loop, 1 is a key and P is a value. And then I go to the next one, okay? And we got A and 1, okay? And we go, well, is 1 inside my dictionary? Yeah, 1 is in there already. And so what do? We're gonna append A to P. So now I'm gonna get a list with the letter P and the letter A, okay? And so we're gonna run this and we get invert on the inverse, and unfortunately I didn't print that out. So the result, I guess I should do it like this, okay? So the result of this is we get a dictionary with 2 elements, okay? The first key, or the first key is 1, and it's associated with the letters P, A, O, and T. And then the second element in dictionary is 2, or the second key in dictionary is 2, and it's associated with a list with the letter R, okay? Yeah. Oh, I'm sorry. I guess the first thing is that when we set the key as the value, we put key inside the square brackets to say we're going to have a list with key inside there. Okay. So so the result of that is a dictionary with 2 keys, 1 and 2. First key has the list PAOT, and the second key has the list with the letter R. Okay. Oh, and just on time. The last thing is, so you can have different kinds of keys. You can have string keys, you can have integer keys, you can have basically any kind of hashable, immutable object as a key. If you try to use a list is a mutable object, so that cannot be used as a key. So here I've got T is a list, D is an empty dictionary, and if I try to do assign, the word won't work, the string won't work to a dictionary with a list T. It tells me unhashable type list. Okay. All right, so that is our very can true and false be used as keys? I've never tried. My gut feeling is no, but who knows? Let's try this out. Let's try this out. True is going to be yes, and false. Yes, no. Okay, does this work? Oh, look at that. It does. True and false can be used as keys. Okay. Yeah. It feels weird doing that, but and we can, you can have letter D. You can have mixed types as keys. Okay. So I can say, what is D on 4? Oops. I'm sorry. D on the letter D. That's the value 4. That's D on true. That's still yes. Okay. So the keys can be mixed types, and apparently you can have a key for true and false as well, which I guess makes sense because they are immutable, hashable values. So so there you go. Okay. There's a little bit more on dictionaries itself. There's a kind of a neat example using creating the Fibonacci sequence here. Oh, quiz. I totally forgot. And I left, let's see. Okay, scratch today's quiz. I forgot about it. Okay, sorry. I had a test for the other class and I forgot that we have a quiz. So I didn't make, okay. No quiz today. Thanks for coming, everybody. We'll see you guys on Friday, and I'll work on your next homework assignment, and I hope your current homework assignment's going well. All right, see you guys.